Hi everyone, welcome to MathsPar. This video is about frequency distribution. Let us know some terms related to grouped data and class intervals. Suppose if you take 0 to 10, 10 to 20, 20 to 30 and this is class interval and frequency as some 2, 3 and 4. Then an inclusive form, that is 1 to 10, 11 to 20, 21 to 30 and frequencies given as 3, 2, 4. Then if you consider this class interval table, then in this, what is the lower boundary of the second class interval? Second class interval is 10 to 20. So lower boundary is 10. Then what is the lower limit of the second class interval? Lower limit is 10. Then what is the true lower limit of the second class interval? True lower limit of the second class interval is 10. Then the same three questions, if they are asked for this inclusive form, then the result is going to change in some cases. That is, what is the lower boundary of the second class interval? So we cannot write that lower boundary of the second class interval here as 11, which is absolutely wrong. Then what are we supposed to write? You have to correct these class intervals into class boundaries. How do we correct these class intervals into class boundaries? So class interval, class boundaries, then frequency. So now here 1 to 10, 11 to 20, 21 to 30, you can correct these class intervals which are in inclusive form to exclusive form. When you write in class boundaries, how to make this as exclusive? This 1 you have to reduce by 0.5 and increase the upper limit by 0.5. So now the class boundary has become 0.5 to 10.5. Then the second one is 10.5 to 20.5. Then the third one is 20.5 to 30.5. Now the lower boundary, of the second class interval is 10.5. Then what is the lower limit of the second class interval? Lower limit can be written directly, that is 11. Then what is the true lower limit? True lower limit of the second class. So true lower limit of the second class interval is nothing but the lower boundary, that is 10.5. So this change you have to observe when we do continuous class interval and discontinuous class interval. Then how do we find class mark of given class intervals? Class mark can be found by upper boundary plus lower boundary divided by 2. Please do remember this word boundary. You are not supposed to add limit in any case. Class mark is also called as mid value of the class interval, and you have to always find the class mark by writing the given class intervals in class boundaries if the class intervals are given in inclusive form. Suppose if a question is given like class intervals 1 to 10, 11 to 20, 21 to 30 with frequencies 3, 2 and 5 respectively, and such questions are asked, how are we going to solve this? You have to draw a table which has class interval, class boundaries, class mark, and then frequency as its columns. Now first 1 to 10, then 11 to 20, 21 to 30. Then class boundaries 1 to 10, you will write it as 0.5 to 10.5. 11 to 20, you write it as 10.5 to 20.5. 21 to 30, you write it as 20.5 to 30.5. Then class mark. What is this class mark? Upper boundary plus lower boundary divided by 2. That is 10.5 plus 0.5 divided by 2, which is 11 by 2, 5.5. If you notice a change here, even if you, for a discontinuous class interval, even if you add this lower limit and upper limit and divide by 2, then also you will get the same class mark. Class mark is also called as mid value. So 10.5 plus 20.5 divided by 2, that is 15.5. Then 20.5 plus 30.5 divided by 2, that is 25.5. Then frequency 3 to 5. Now this table is completely ready to answer the given questions. Lower boundary of the second class interval. Second class interval is 11 to 20. What is the lower boundary of second class interval? Means 10.5. Then upper limit of the third class interval. Third class interval is 21 to 30. Lower limit is 21, upper limit is 30. So you will write 30. Then class size of first class interval. Now what is this class size? Class size is nothing but how many numbers are included in this class interval. Now here inclusive class interval. So 1 is included, 10 is also included. So you can count from 1 to 10, which is nothing but 10, or else upper boundary minus lower boundary is nothing but its class size. So 10.5 minus 0.5 is 10. So for any class interval, the class size remains same in this table. Now class mark of third class interval. Class mark of third class interval. Third class interval is 21 to 30. And in this class mark is nothing but 25.5. Next, true upper limit of first class interval. First class interval is 1 to 10. True upper limit is nothing but the upper boundary, which is 10.5. Then true lower limit of second class interval. Second class interval is 11 to 20, where 11 is lower limit, but true lower limit is 10.5. This is how we answer a given question by writing the different specifications, class interval, class boundaries, class mark and frequency. Thank you.